This video is for your subject Science and Technology, Paper 1. In this video, we are going to study the Chapter 1, that is Laws of Motion. Students, let us now look into the concept of uniform and non-uniform linear motion. Consider three friends, Amar, Akbar and Anthony, are traveling in different cars with different velocities. The distances covered by them during the different time intervals are given in the table. Now, what is the time interval between the noting of the distances made by Amar, Akbar and Anthony? Students, the time interval is given in this first column. If you look at it, the initial time is 5 o'clock. Then the next reading is taken at 5:30. The next is at 6 o'clock and so on up till 8 o'clock. So the time interval is of half an hour. Okay. Then what or who has covered the equal distances in equal time interval? Now if you look at the distance covered by Amar, Akbar and Anthony. So if you see and calculate, then you will notice that Amar has covered an equal distance of 20 kilometers in each interval. The distance covered by Akbar is not equal in every time interval, while that the distance covered by Anthony is same in each time interval and it is 14 kilometers. Now the distance covered by Akbar in all the fixed time intervals is not same. Now if you consider all the distances covered by Amar, Akbar and Anthony in the fixed intervals and calculate the total distance travelled by each of them in this period of 3 hours, then you will see that Amar has travelled 420 kilometers in 3 hours. Akbar has travelled 381 kilometers in the 3 hours. And Anthony has travelled 294 kilometers in this 3 hours of time. So Amar has covered maximum distance in the given time period, while Anthony has covered the least distance in that given time period. Students, if an object covers equal distances in equal time intervals, then it is said that it has been moving with uniform speed. So uniform speed can be defined as if an object covers equal distance in equal time intervals. Now, which two friends show uniform speed? Amar and Anthony show uniform speed because they are covering equal distances in equal time period. Whereas in Akbar's case, the distance is not equal. So not equal means non-uniform. So Akbar has non-uniform speed. Now an object, if it covers unequal distances in equal time interval, then it is said to be moving with non-uniform speed. That is, non-uniform speed can be defined as if an object covers unequal distances in equal time intervals. Students, now let us understand the graphical representation of motion. Okay, students, you all know what are graphs. In your lower standard in mathematics, you have drawn graphs representing a given data. Graphs help us understand the given data in a much simpler and easier format. So in this topic over here, we are also going to use the graphical representation for motion. The graphical representation for motion. So the first graph which we are going to look into is the distance time graph. The distance time graph. The distance time graph for uniform motion. Distance time graph for uniform motion. We all know what is uniform motion. Okay. Now, while drawing graph, we drew the coordinate axis. The coordinate axis consists of two straight lines which are perpendicular to each other, like this. This is the x-axis, the horizontal axis is the x-axis, and the vertical axis is the y-axis. Now, the x-axis and the y-axis represents some quantity, and the graph which you drew gave us a relationship, or helps us to understand the relationship between the two quantities. Okay. Now here what we are going to do is we are going to draw a distance time graph. So the two quantities which we are going to consider is distance and time. Okay. On the x-axis we are going to consider time. We are going to consider time on the x-axis, and we are going to consider distance on the y-axis. Understood? So we are going to consider time on the x-axis and y on the distance on the y-axis. Now we are going to draw a distance time graph for an object in uniform motion. So let us consider a data for an object. Okay, like this. This will represent time and this will represent the distance covered. We will consider s as the variable for distance. Okay. Now say consider at time 0 second the object is at rest. Object is at rest means the distance covered by object is 0 meters. At time 10 seconds the object covers 15 meters. At, I will not write this, I don't want you to get confused between this seconds and this s. Okay. At 20 seconds the object covers 30 meters. At 30 seconds the object covers 45 meters. I'll only consider these points, okay, for the time being. So what we are going to do is we are going to represent all these points on this graph. Okay. While drawing the graph, this point of intersection is always 0. This is called as the origin. Okay. Now time is represented on the x-axis. So all these points will come on the x-axis. So let us see how the time is moving. 0 is 10, 10 to 20, then to 30. So I have got 10, 20, 30, 40 and so on. Okay. See, equal distance must be maintained between each points. Equal distance must be maintained between each point. Now, distance is moving this way. So how is the distance going? 0 to 15 to 30 and to 45. So this will be, say, I'll take this as 15. This is 30 and this is 45 and this will be 60. Okay. Now you write a scale over here. So for x-axis and for y-axis. Okay. For x-axis and for y-axis. X-axis, what do you have? You have got, I'll say 1 centimeter, is equals to 10 seconds, and for y-axis 1 centimeter is equals to 15 meters. Okay, so I have represented the scale for the graph which I am drawing. Now let us start plotting the points. At 0 seconds the distance is 0 meters. So at 0 seconds the distance covered is 0 meters. Done. Now at 10 seconds, how much is the distance covered? 10 seconds, the distance covered is, yeah, how much? 15 meters. The 10 seconds, the distance covered is 15 meters. At 20 seconds, the distance covered is 30 meters. At 30 seconds, the distance covered is 45 meters. Now students, if you join these points, see what you get. If you join these points, you will get a straight line. Now, for a uniform motion, for an object in uniform motion, the graph is always a straight line. For an object in uniform motion, the graph is a straight line. Now, from this graph, we can learn about two things. One, we can find out the distance covered by the object at any given instant. How is that possible? All you have to do is you have to just pick out at what time you have to find out. For what time you have to find out the distance is covered. For example, if you want to find out the distance covered in 40 seconds. So what you're going to do is you're going to draw a perpendicular line from 40 going straight up like this. And from this point, you're going to draw a perpendicular line on the y-axis like this. So at 40 seconds, the distance covered is 60 meters. Understood? The second thing which you can get from this graph is the speed of that object. You can get the speed of that object. Now, how can we get the speed of the object? Now, speed is distance covered upon time taken to cover the distance. Understood? This is the formula for speed. Speed is equals to distance upon time. Now, a straight line means the speed is constant. A straight line over here represents that the speed is constant. Why? Because the motion is uniform motion. So, we can take any 2 points on this line and that will help us find out the speed of that object. Okay, now for instance, let us consider this point as A, and say this point as B, this point as A and this point as B. So with the help of these 2 points, we can find out what is the speed of that object. Okay, now to make things easier, what I'll do is I'll just erase off the rest of these lines so that you will have a clear picture about what I'm trying to say. Okay, now when the object is at A, it is at this point, and when the object is at B, it is at this point. So the distance covered while traveling from point A to point B will be from here to here. Okay, so what I'm going to do is I'm just erasing this part. You all know this represents distance. Okay, so at point A, let the distance be S1, and at point B, let the distance be S2. Okay, so what is the distance covered while traveling from point A to point B? The distance covered the distance covered is S2 minus S1. Okay, so distance covered from traveling from point A to point B is S2 minus S1, and the time taken by the object to reach from point A to point B will be given by T2 minus T1. T2 minus T1. Okay students, now let us move forward. S2 minus S1 means 45 minus 15. See, S2 is 45 and S1 is 15. T2 minus T1. So T2 is how much? 30 minus 10. So 45 minus 15 is 30 and 30 minus 10 is 20. So this becomes 1.5 meters per second. So the speed of this object in uniform motion is 1.5 meters per second. I hope students you have understood this distance time graph for uniform motion and how to find speed using this distance time graph for uniform motion. Okay students, now since you have understood the distance time graph for an object in uniform motion, let us now look into the distance time graph for an object in non-uniform motion. For an object in non-uniform motion. Now let us consider a data like this. An object in some time has covered some distance. Okay. So I would say 10, 20, 30. Distance is 0. This is 5. This is 15. And this is say 30. Okay. Now what we are going to do is we are going to represent this data on a graph. So we draw the graph, the x-axis and the y-axis. So this is the x-axis and this is the y-axis. Now distance time graph, the x-axis and the y-axis will represent the time and the distance respectively. So on x-axis I'm going to note the time, and on this I'm going to note the distance. Okay, 0. See how is the time moving forward? Multiples of 10. So you got 10, 20, 30, 40 and so on. For time, sorry, for distance you got 0. I will write 5, 10, 15, 20, 25 and say 30. Okay. Now let us try plotting the points. At 0 seconds the distance covered by the object is 0. At 10 seconds the distance covered is 5. At 20 seconds the distance covered is say 15. So you got something like this. And at 30 seconds the distance covered is 30. So you got something like this over here. Okay. Now when you join these points, let us see what type of graph you're getting. Is it a straight line? No, this graph is not a straight line. So for a non-uniform motion, when you draw a graph, the graph here is not a straight line but a curve. Okay, understood? Over here also you can find out the speed, but the speed will be varying. Okay, over here also you can find out the speed, like for consider this as point A and this as point B, and this as T1 and T2, and using the same concept you can find out the speed of the object between these points. But students, remember over here, since the graph is not a straight line, the speed will not be constant. So the speed will be varying and always be changing. Okay, students, you have understood the distance time graph for an object in uniform motion and the distance time graph for an object in non-uniform motion. Now let us move forward and study the third graph of your topic. The third graph is the velocity time graph for an object in uniform velocity. Velocity time graph for uniform velocity. Okay, students. Now we are going to consider an object moving with a uniform velocity. Velocity is what? Velocity is nothing but the distance covered per unit time, or the displacement covered per unit time. Now, velocity, the unit is kilometers or meters, kilometers per hour or meters per second. And the time, the unit is seconds. So let us consider a train which is moving with a uniform velocity of say 60 kilometers per hour. The uniform velocity is 60 kilometers per hour, and say that the time, or it moves for 60 kilometers per hour for say 5 hours. Okay, so now let us try to represent this data on a graph. Okay, so what we are going to do is we are going to draw the two axes, the x-axis and the y-axis. This is x and this is y. Okay, on the x-axis we are going to represent time. We are going to represent time on the x-axis, and we are going to represent velocity on the y-axis. Time on the x-axis and the velocity on the y-axis. Okay, so the time we are having is say in hours. So we'll say this is 0, 1 hour, 2 hours, 3 hours, 4 hours and 5 hours. Okay, velocity 10, 20, 30, 40, 50, 60. Okay, in the first hour, what is the velocity? We say it is 60, uniform na, so we say it is at 60. In the second hour, the velocity is again how much? 60. In the third hour, again the velocity is 60, and so on. And so if you notice, it is a straight line. This graph is going to be a straight line. Why? The velocity is constant. Understood? Now, using this data, using this given data, we can find out the distance covered by that object in the given period of time. Okay, now we are going to use the same formula for speed. Now speed is equals to distance upon time. Speed means velocity, Okay, so what if you want to find out distance, the formula will change to distance is equals to velocity into time. So the distance will be velocity into time. Now, as I said, for uniform velocity or for uniform motion, you have a straight line, and using that straight line, you will be able to find out the distance or the speed at any given point. Okay, so we'll consider these 2 points. I'll just erase this line. We'll consider this point and this point. Okay, this is point A and this is point B. Okay, now, and then these are the 2 points. Okay, now this time, this 2 represent time at the initial point, that is t1, and this 3 is t2. Okay, 2 is t1 and 3 is t2. So distance is equals to velocity into time. Okay, so what is the velocity at both this time? There is no change in the velocity, so the velocity is 60. And what is the time? The time period is t2 minus t1. t2 minus t1. So this is 60 into t2 minus t1. So 3 minus 2, that is 60, sorry, into 1, that is equals to 60 kilometers. This is 1 hour, hence 60 kilometers. Okay, now what we will do is we'll take one more point, say point C. Okay, so point C is at this. So this is T3. So let us find out the distance covered from moving from point A to point C. Okay, so this is case 1. So what I'll do is I'll just erase this part. So velocity is again constant at 60. Time will be what? T3 minus T1. So T3 minus T1. So 60 into 4 minus 2. That is equals to 60 into 2. That is equals to 120 kilometers. Students, I hope you have understood this concept using the graph. Now look at this point. If you look at this point A, C, I'll say this point D and E. Looking at the point A, C, D and E, you can see that this is a rectangle. This is a rectangle where AE is the length and DE is the breadth. AE is the length and DE is the breadth. So this velocity is represented by AE and the breadth is represented by this time taken by that object to cover that much distance. Okay, now you have got velocity into time. So velocity is what? Velocity is AE. Velocity is represented by AE and time is T3 minus T1, means this DE. Now for quadrilateral ACDE, AE into DE is what? Area. So in order to find out the distance between the distance covered by the object in the given time, what we are supposed to do is you're supposed to find out the area under the graph. So this area will give you the distance covered. I hope this point is clear. So students, you have understood the velocity time graph for uniform velocity. Now we'll move forward to the next type of graph, that is velocity time graph for uniform acceleration. Okay, velocity time graph for uniform acceleration. Students, we are going to consider a data. Okay, an object moving with uniform acceleration. Acceleration is nothing but rate of change of velocity, and here we are considering an object having a uniform acceleration. Okay, so for time t and velocity 0, 0, 5, 8, 10, 16, 15, I've got 32, and for 20 I've got, sorry, for 15 I've got 24, and for 20 I've got 32. Okay. So this is the data given. We are supposed to draw a graph for this data. So we are going to draw the x-axis and the y-axis. The x-axis and the y-axis represents time and velocity. Time and velocity. Okay, this is the origin, this will be 0. Now let us look at time, how it is moving forward. 5, 10, 15, 20, 25, and so on. And velocity, how is the velocity changing? 8, 16, 24, 32, and so on. Okay, now when the time is 0, the velocity is 0. When the time is 5 seconds, or when 5 seconds have passed by, the object is having the velocity 8 meters per second. So the velocity is 8 meters per second. At 10 seconds, the velocity of the object is 16 meters per second. After 15 seconds, the velocity is 24 meters per second. And after 20 seconds, it is 32 meters per second. Now, if you join all these points, you will notice that you get a straight line. Now, the straight line means that this object is having a uniform acceleration. Now, using this graph given, we can find out the distance covered by the object. Okay, now let us consider to find the distance covered by the object between 10 seconds and 20 seconds. Consider we have to find the distance covered by the object between 10 seconds and 20 seconds. I'll just erase the rest of the lines so that there is no confusion. Okay. Now, as we know from the previous graph, the distance covered by the object between the two time periods is given by the area of the quadrilateral below the graph. The quadrilateral over here is a trapezium. I will just give a name to the vertices. Say this is A, this is B, this is C, and this is D. Okay. Now, the distance covered by this object is given by the area of this trapezium ABCD. Now, if you don't know how to find the area of the trapezium, what you can do is you just draw a perpendicular over here, say E. Okay, so you got distance is equals to area of quadrilateral ABCD. Area of quadrilateral ABCD, which is equals to area of triangle AEB plus area of quadrilateral AECD. AECD. Okay, AECD. Now let us find out the area of triangle AEB. Area of triangle is half into base into height. So half into, what is the base? AE. The distance AE is given by T2 minus T1. So 20 minus 10, that is equals to 10. And BE, the distance is given by 32 minus 16. So that is 32 minus 16 is 16. Plus area of this quadrilateral AECD. AECD is a rectangle. So EC, how much is EC? EC is 16 minus 0, that is 16 into, and how much is DC? DC is again 10. So this becomes 8. So this becomes 80 plus 16 into 10 is 160. So that becomes 240 meters. Since the velocity is in meters per second, so the distance covered is 240 meters. Understood, students? Now, this velocity and time graph for uniform acceleration can be also used to find the acceleration of the given object. Okay, now how can you do that? I hope this is clear to you all how to find the distance covered. The distance covered is the area under this graph. The area is of the trapezium over here. How did I find the area of the trapezium? I made this or split this trapezium into two parts, which is one triangle up over here and one rectangle over here. So the area of this triangle plus area of this rectangle, and I have got the distance covered as 240 meters. Now, acceleration is what? Acceleration is nothing but the rate of change of velocity. So formula for acceleration is final velocity minus the initial velocity upon the time taken. Over here it will be T2 minus T1. Okay, so we'll consider acceleration from point A to point B. So point A, this is U, initial, and point B, this is V, the final. So how can you find the acceleration between point A and point B? V minus U. V is how much? V is 32 minus how much is the velocity at A? It is 16. T2 minus T1. T2 is how much? 20 minus T1 is how much? 10. That is equals to, this is 16 upon 10. That is equals to 1.6 meters per second. So acceleration is 1.6 meters per second. Now students, since our acceleration over here is positive because the speed is increasing. See, from 0 it went to 8, then it went to 16, then it went to 24 and 32. So since the acceleration is positive, our graph is moving in this way. Just imagine what will happen if our acceleration is negative, which means here the vehicle is moving ahead. So what will happen when you apply brakes to the vehicle? What will happen? The velocity will decrease, and this, I'm just erasing this part, and this is y and this is x. Okay, and the graph will be like this, and the graph will be like this, where acceleration is negative, here acceleration is positive. Got it? So for varying acceleration, your graph will also change. For example, if a vehicle is moving in traffic, so how will the graph look of velocity and time with respect to the acceleration? What will happen? when the vehicle is moving towards the traffic, the acceleration is positive. When it comes more near, the driver applies the brake, the acceleration drops down. When the traffic starts moving, again the driver accelerates, so it moves and it comes down and move. So here you can see the acceleration will change depending on the speed of the vehicle. Okay, I hope you have understood all the different graphs which we have for this chapter.